remember that when we're looking at these, what we want to do is figure out what is happening to get from one number to the next to the next. So we have from negative 23 to negative 17 is adding 6. From negative 17 to negative 11 is still adding 6. Negative 11 to negative 5 is adding 6. Negative 5 to 1 plus 6, and it is going to be plus 6 all the way down. And remember, when it is the same thing all the way down the first time, what we have is a linear pattern. So when we have that linear pattern, what we want to do is we want to write a recursive equation. So with a recursive equation, we always start with f of n equals f of n minus 1. That's an equal sign, sorry. And then if it's linear, it's just plus or minus whatever is actually happening every time. So this number right here is always going to come from whatever is happening every single time. And remember, you always have to give a start value as well. Doesn't matter what row in the chart you pick. F of 0 equals negative 5. I tend to pick whichever one is the f of 0, but it doesn't really matter. I'll have whatever on there as an answer key option. So just make sure you pick one of the patterns or one of the start values. Okay, so now the ones that are a little bit trickier are ones like number 4. Okay, so if we look at this, and these are straight out of your book. These are on page 4 out of your book. If you're looking at number 4, what is happening here? We are going down by 4. We are going down by 2. We are not changing at all, so plus 0. We are going up by 2, up by 4, and up by 6. So you notice it's not consistent, so we know it's not linear. So then what we have to do is take the second difference. So when we take the second difference, we are adding 2, adding 2, adding 2, adding 2, and adding 2. So you notice that now it is finally consistent, which means it is quadratic. Sorry. Okay, so if it is quadratic, we have to do our recursive still, but the problem becomes that it's a little bit more labor intensive. We have a little bit more we have to do. So it's going to be f of n equals f of n minus 1. And just like before with the linear, whatever we got to be our consistent value, this plus 2 is actually going to be plus 2n plus blank. And this is why we have to do a little bit more work here. We actually have to figure out what goes in that blank. So the way that we do that is we pick an n, and it can be anything from the chart as long as it is not the first row. So let's pick n of 1. So we're going to say that n is 1. So then everywhere in this function that we see an n, we replace it with 1. So f of 1 equals f of 1 minus 1 plus 2 times 1 plus blank. And then we move on and actually simplify and do that. Well, f of 1, what that means is you go to 1 on the left side of your chart, right here, and you find what is the function value at that point. So f of 1 is 0. So we're going to replace that. Because f of 1 is equivalent to 0, we can replace it in our equation with 0. And then from there, we just simplify with the other pieces. So this is f of 0 plus 2 plus blank. And now we see that we need f of 0 as well. So let's look in our chart, and we see f of 0 is negative 2. So then we want to plug that in. So 0 equals negative 2 plus 2 plus blank. So, and we see that when we plug that in, we actually are just going to continue to simplify. So 0 equals 0 plus blank. Well, that means that nothing really goes in our blank, so it is also a 0. That isn't always the case, but sometimes it will be the case. And the last thing we need to make this a recursive is we have to have a starting point, which we actually did put up here, but you can easily rewrite this. I just circled 0 and wrote 1. Sorry. So we need to have that as our final